Hello everybody, welcome to the Programming and Data Structure course at the Indian Institute of Technology Kharagpur autumn semester 2020. So this is the continuation of our previous two video lectures on pointers. In one lecture we demonstrated basics of pointer where we discussed that how to store that address of a variable and how we can access the content of a variable through its address by storing that one in a pointer, and next we extended that one for array. Now in this video lecture we wish to show you the applications of pointers in function. When I say function, then you understand that there are multiple functions, and when multiple functions are there in a C program, considering the scope and visibility of a variable, you understand inside a function there may be one or multiple variables declared, but their scope and visibility is inside that function. Okay, even if it is static, then it is inside that function, but its lifetime will be throughout the program. And since the lifetime, since the visibility and scope of a variable is inside a function, that's why we can have same variable name in two different functions. That's why if we alter the value of a variable inside a function, then that altered value is not visible from other function. That is one kind of bottleneck or problem that you noted, where say I am calling one function from function main. If I assume that okay, I am calling function say fun1 from function main, and in fun1 if I modify some value, then after coming back to the main function from fun1, that particular value will not be returned. That is what we discussed as of now, and we call that one as call by value. Primary reason is that content is being copied to that local variable inside that particular function in terms of the argument, and when I will come back, then the changes occurred in that function is not reflected here. Okay, if you return that one, then it's fine, but then also the problem will be at a time I cannot return more than one. But using pointer we can make some changes in one function, say the function which is called from another function, and that changes can be retained when I will come back from that particular function. So that is the primary agenda for today's discussion, and that is one of the major applications of pointers. In order to do that one, we need to pass the pointer. Now you know that when I am calling to pass the pointer, then pointer is nothing but the address or memory location of a variable. So I am passing that one to one function. Now that particular address or memory location will be copied locally there. But from that function, if I access the content of that address, then the content will be same as from the function from where I have called that function. Shortly I will show you one example, and then you will understand it in more detail. Okay, that way using the indirection, basically we can have it, we can make some changes in a function and which is being reflected from the called function, and that way we can have more than one values changes in the value change in that particular function where which one is called, and that will be reflected in the call function. Okay, still call by value, but now address is copied, not the content, so the changes will be there. So this particular way of passing the parameter is called as the call by reference or by address or by location, because we are not passing the content, rather its address or its reference or the location. Okay, normally we know that we can pass only the value. Okay, and in case of passing by value, the content is not change. I mean, the change in content is not reflected. So the prime example is this one, swapping two variables. If I look at this integer main, then you see that there are two integer variables a and b. This is just for the demonstration purpose. It can be integer, floating point or anything. My intention is to check that whether the call by value works if I wish to swap the content of these two variables. So a equals to 5, b equals to 20. And I know that if I print here that what will be the value of a and b, then it will be printing as 5 and 20. Now I am calling swap and I am passing a comma b. Now by this time you are familiar with the situation and the notation also. If I write swap a comma b, then in swap function the content of a will be copied to x and the content of b will be copied to y. So in main function, two memory locations are reserved, one for a, another for b. The content of a is written as 5, content of b is written as 20. Now when I will call from this function main swap and the argument is int x and int y, then in swap two variables will be created. One is x, another is y. That will be created locally inside this swap. It is visible as well as its scope is inside this swap only. Then the content of a will be copied to the content of x and the content of b will be copied to the content of y. Then what I am trying to do, basically I wish to swap the content of x and y. So int t is my one temporary variable. Initially I am taking the content of x in t, then I am overriding the value of or content of y in x, then I am taking back the value of t which is actually assigned as x to y, and after the three statements actually the content of x and y will be swapped, and that is the swapping function. Now you see, since the content of a will be copied to x and the content of b will be copied to y, so after the swapping the content of x will be the content of y and vice versa. Then I am returning from this function. After returning that one, so when I will come back, then the scope and visibility of x and y is lost in function main. So if I print a and b, then it will print the same thing 5 and 20. There is no swap occurred. And also you understand that there are two values, so I cannot just write return say x or y. And if you think of say, okay, I will return x, then I will compare whether it is a or b, then I will write so blah blah blah. So yeah, so that way you can do that one, but there is a very simple way also. I am demonstrating that one, but clearly this is one of the primary limitation of the call by value, that the changes which is made in a function, if I wish to retain in the callee function, it will not be retained. Okay. Now the changes I wish to do here is, instead of a and b, I will pass their address of a and address of b, I will pass that one. Okay. Now if I pass the address of a and address of b, then I have to store that as a pointer. So now you see that int star x is the declaration of a pointer variable x whose data type is int. Similarly, declaration of a pointer variable y whose data type is int. This is not indicating the content of x or content of y. Now here in x, the address of a will be copied. In y, the address of b will be copied. And it's also true that throughout this program I did not have to change the address of A and B. But what I need to change is the content of A and B. So again I am having int t, one temporary variable you can consider. Now star x here is indicating the content of A using the pointer concept. That will be copied to t. Then the content of y will be copied to x, content of x, that is A. Then the content of t will be copied to the content of star y, that is the B. Now after this one you see that x and y is not changed, and also that is not required. And also when I will come back, then the value will be written. Why? When I am doing this, say I am assigning dot y to dot x, then actually the effect is taking place at the memory location where A and B is. So the difference is, in the last case when it is A and B, only the content was copied, but when I mentioned ampersand A and ampersand B, so address is passed to this function swap, and here I am doing the operation on the content, and the star x indicates that okay, x is having the content of x is having as a content address of some integer variable. So you go to that address location and do the changes. So changes which is occurring because of these two assignment statement is at the memory location of A and B. Yes, local copy of x and y is created, which is not visible when I will come back from swap, but that is to store the address of A and B, not the content of A and B. Is that clear? That's why if I print A and B after calling this swap function, then you will see that A is printed as 20 and B is printed as 5. So this is your first example of passing parameter, and that way changing the content by swapping. Okay. Now while passing a parameter to a function, okay, so you have to be sure that the parameter value will be modified inside the function body, because in the same memory location it will be actually copied, and the modified value is indeed in the calling function after the called function returns. Okay. So just now we have seen the swap function and its application here. Now you can extend that concept, that simple swapping function concept, to sort three numbers using swap function. So what I am asking you to do, that you read three numbers from the input. You can consider A, B, C. You call just the swap function, that you have to decide how to call that one, because swap function will take two arguments as an input, basically the address of two arguments as an input, and by that way you may call several number of times, and indeed you have to call multiple times this swap function, and by calling that one you get the number sorted. I am not talking about the efficiency of this implementation, but I am talking about the usefulness of the swap function and demonstrating that how the pointer can be used for swapping. Okay. Now to revise the concept of pointers and arrays before we proceed for passing the arrays to the function using the pointer. So when an array is declared, so what is important is its base address. Okay. Now if I know the base address, which is also the address of its 0th element, then using that one I can access other elements also, that we have demonstrated. Okay. So that base address can be stored as a pointer variable, and data type will be same as the data type of the array. Okay. Now here are two different ways or representation for passing arrays as pointer. Both forms are allowed. If I start from the left hand side and focus on main first, then I am declaring one list variable which is an array of floating point numbers and size is 100. then average, and say I am computing the average by passing n and list. Now here I am receiving int a. Now please note that n is not important after coming back, and whether if there is a change then that is not required. I am not showing you full program now, that I will show you later, but I wish to draw your attention to this red color. So here I am writing float x square bracket. That is interesting indeed. So first of all, while I am writing this one, I am not actually copying the content of list. I mean, I am not copying the elements in list to array x. But what I am doing, I am just copying the address of list, the base address of list, or the address of the 0th element of list to x. And in order to do that one, I am declaring this x as a pointer variable. Now this is on the right side, this is familiar declaration that is same as in the swap what we have done, and in this case instead of star I am using square bracket. Now please note that some dimension of the array inside the square bracket is not important, because by looking at this square bracket, it will understand, the compiler will understand that it will store the address of some array variable. Now since by address I mean the base address of the array variable. Now this base address indicates that address of the 0th element, and also you understand by this time, specifically when we discussed the array and pointer, then it is not required to store the dimension of the array, but you can keep track of the dimension of the array so that I cannot go beyond the declared size. But if I have the base address, then similarly to the array declaration, using that base address I can directly access that element. So here is an example. So float x square bracket, then xi I can access. Similar to here also, if I write float star x, then xi I can access in that way also. Okay, so the full program is here. Okay, so from here first I am reading the numbers. I am asking that how many numbers you wish to enter. I am assuming that that will be something less than 100. Then I am reading them one after another and storing in an array. Then I am calling the function average with the array as well as the size of the array, that is xn, and the return value is the average. I am printing that one directly using %f. And inside the function average, so I am declaring one array parameter and one integer parameter. So int array will be storing the address of x, that is the base address of x, and this n integer will be copied to the sum. And here I can have one more pointer declaration. It is redundant, but this will demonstrate that I can write this way star p and then p equals to array. So again I am copying the pointer to another pointer variable, and I am using this pointer variable to access that one. Now you see, since the content of this array is nothing but the base address of x, the content of p is copied from array, then the content of p is also base address of x, then I can write, instead of say pi or array I can write p plus I and then star, then it will increment, and then after the increment the content will be printed. And finally I am doing the division and returning the value. Now during the division, since I am reading integer values and size is also integer, so if I do not do this typecast, then there is a probability and it will be actually, the division will be integer division. So either I need to typecast or I need to multiply with some, multiply it with 1.0, something I have to do. Okay, or I can declare sum as a floating point number. Okay, so some conversion to the floating point is required. Okay, so here is a further example that p, last time what I did, p plus I star. Now you understand that this can also be written as p square within square bracket I. Okay, so the pointer p can be subscripted also just like an array. Now the arrays and pointers, an array name is an address or a pointer value. Pointers as well as arrays can be subscripted. A pointer variable can take different addresses as values. An array name is an address or pointer that is fixed. It is a constant pointer to the first element. Now the arrays, its consequences are AR is a pointer. AR0 is the same as star AR because AR is a pointer to the and it will indicate the base address. So if it is the base address, so it is the address of the 0th element. Now if it is the address of the 0th element, if I write star A, that is equivalent to AR0, because this I can also write star AR within parenthesis AR plus 0. Similar to here, AR2 is the same as star AR plus 2 within parenthesis. We can use pointer arithmetic to access arrays more conveniently, and declared arrays are only allocated while the scope is valid. Okay, but this is not correct, that I am declaring one variable here and then I am returning the address. So this is not correct. Now regarding the size or dimension of the array, so what we used to give an integer constant as an array size, but this kind of declaration like int I n equals to 10, int ar n for I equals to 0, I less than n, I plus plus, in this case this array declaration is not allowed. Even though you may not get an error, but if you switch on your warning by writing WALL, switch on all the warning, then basically you will get some warning messages, and you cannot allocate an array whose size is a variable. So here, although you may argue that n is initialized with 10, but that initialization is done during the program execution. But compiler needs to know what will be the dimension of the array in this kind of static allocation during the compilation process. Okay, so even if you do not get an error and program executes, but this is not a correct way of declaring array. On the other hand, the second one is correct. Here I am writing has defined array size 10, then int I a array size, and this one. But you know what is the difference between these two? In this case n is an array, and in this case this is a macro definition. So all the macro definitions are expanded during the pre-processing stage of a compiler. Okay, now before the actual compilation starts, all the macro processors are expanded. So when the compilation will take place, then this 10 value will be replaced here. But that is not true for here. This is a variable assignment, and also you can extend this one when say it is only int I comma n, no value is assigned, but after that one you have some scanf and you are expecting user will give you the input, and based upon that one you declare the array size. So that way you cannot have this kind of declaration. This is called as the static declaration, where compiler should know that what is the dimension of the array. But definitely that kind of situation may happen. We understand that during the program execution, user will supply me that what will be the dimension of the size, and is there a way out to declare the array size based upon that supplied information? Yes, there is a way out. For that we will go for dynamic memory allocation, that will be discussed in some other class. But for the timing, you can consider this is not an allowed declaration of array, this is allowed, and this is a macro one, and this is an integer variable. Okay, macro ensures that when compilation starts, the dimension of the array is an integer constant, but it doesn't guarantee on that. Now arrays in functions, so we demonstrated that it can be using square bracket or it can be using star s. So I guess by this time you are familiar with these two string length functions in different types it can be, so you can pass this way or this way. Okay. Now we discussed extensively about this arrays and pointer. So again this is provided here. You can consider this as your study material. Okay, so when an array is declared, the compiler allocates a sufficient amount of contiguous space in memory. The base address of the array is the address of A0. By this time I believe that you are aware about this one, that is also the advantage of the array, that it is placed in the contiguous memory location. That's why by changing the subscript I can easily calculate that what will be the address for that one by adding the base address of the array with the index of that I. Okay, and here is another interesting representation. So there are three different ways represented here through which you can compute the sum of a list of numbers. First of all, we define the size of the array as 20, define n20. Now int an, now please note this n is not a variable, this is a macro which is defined here. So this n is not similar to what I have shown you few slides before. There int n was there, so int n declares one variable. Here it's a macro. So during the p-processing stage this n will be replaced by 20. So int a 20 I star p sum. P equals to a, I am copying the base address of a and storing that one in pointer variable p, which is equivalent to p equals to star a0. Okay. So okay, I am sorry, there is a typo. So this will be ampersand a0. This will be ampersand a0. Now p is assigned 300. If p is assigned 300, which means the address is 300. So pointer arithmetic provides an alternative to array indexing. P equals to a plus 1 indicates one step incrementation, which means p equals to p incremented to the next element. Assuming 4 bytes are required for integer, so it will be 304. That is same as ampersand a1. So again, so there is a typo, I will rectify in the slide. So this is ampersand, not, it is not star, this is ampersand. Okay. So p is assigned to 304 like that way. Now here you see this for loop. So first I am initializing the base address of array A to p, then I am incrementing the p here, sorry, plus plus p, and the condition is p less than ampersand an, that is the last element in the array. Okay, so this less than, so instead of say varying I equals to 0 to I less than n, I plus plus, I am doing this on the pointer, and then I am adding some plus equals to star p. Okay, so the star p, as you understand, that will give me the content, since it is incremented plus plus p, so it will keep on incrementing. Okay, now another representation is p equals to a. I am copying the address, then I equals to 0, I less than n plus plus I, then some plus equals to pi. This is also valid, and this is similar to writing ai here. But since I have copied a to p, then I can also write this way. Another way is that, so instead of writing a square bracket I can write a plus I and star here. Now please note that I am not incrementing the base address, so always I am adding a plus I. It is not a plus plus. I am not incrementing that one. Okay. Now I believe that it is clear to you that how to return multiple values from a function. Okay. So in order to return that one, you create one memory location in the callee function, then you pass the address of that variable to the called function. The value will be changed there, and when it will come back, the changed value will be returned. So that is the mechanism. Okay, but return statement can return only one value at a time. But yes, if you think that I have an array and I used to return that one, that is a separate issue. But otherwise, it will return only the single value. Now here is an example of returning max and min of an array. So both return through pointers. Similar to that swap function, what I have done here is that declaring the variables, then array, then scanf %d %n for I equals to 0, I less than n plus plus I, scanf %d %ai. So I am reading the number of elements, then I am reading all the elements and storing that in an array of ai. Then I am calling min max function by passing the array a, size of the array n, and I have created two memory location min and max to store the value, and then I am passing their address in this function min max. Now the printf will print min max. Let us see how it will happen. Now here this is simple integer a. Yes, this is the array. So in square bracket opening and closing, indicating that it is an array pointer. So this is integer n. Then since I am passing ampersand min and ampersand max, and I wish to return min and max values from this function, and I also understand that in one return statement I cannot do that one. So alternatively, what I am doing, that I am declaring two variables int star min and star max. Those are pointer to this min and max, basically storing the address, because I am passing the address of min and max. So it is storing the address there, and all the changes will be on the content of this max, as content of min and max. So here what I am doing, that if so integer I x y, x and y equals to a 0. Okay, now I am storing locally the minimum and maximum in x and y, and finally I am assigning that one to min and max. Okay, now instead of two variables, you can consider to declare one, say array, name is min max, and within square bracket there is 2. Then here I can change that min, I can assume that 0th element, and max is 1 element, and I can make the changes so that when I will come back that will be written. That is also possible. Now the structure and function we have seen in the last video lecture also. Here I will show you that a function can also return a structure. Okay, let us assume the function to add two complex numbers. Now here I am defining first one structure data type, where there are two floating point variables. One is to store the real number, another to imaginary number corresponding to a complex. Then I am declaring three basically the variables a, b, c. So in a I am storing one complex number, in b I am storing another complex number. Then I am calling function add to basically with the address of a, b and c. A and B is not that much required, but C is required. Why? Because in C, which is here star t, I will store the added value, and I expect that when I will come back using the C, I can access that complex number, the real and imaginary part of the complex number. That's why I am storing. Okay. Now it will be good to modify this one. You can consider that as your homework, that instead of say passing a, b, c, is it possible to say return c from here and assign here? Is it possible? Is it possible? You can do that one. You can check that one. That you consider as your homework. Now the actual mechanism behind this array passing is that the array name is interpreted as an address. Array stores in contiguous memory location. So by address I can access all the elements there. Okay. The formal argument therefore became a pointer to the first array element. When an array element is accessed inside the function, the address is calculated using the formula stated before. Changes made inside the function are thus also reflected in the calling program. Next, another interesting and important concept in pointer, that is the typecasting. So starting from pointer basics, I repeatedly mentioned that all the pointer variables irrespective of the data type of the variable stores the address. Now you know that since the address is same for all the data types, the only thing is that starting from a particular address or location, how many bytes will be reserved and how those will be interpreted. So the data type, the different variables differ from each other from that point of view. But from memory address point of view, all the addresses are of the same memory. So for all the addresses, the memory requirement is same and they are nothing but the unsigned int. So from that point of view, there is a similarity. So exploiting that similarity, what we can do, that we can reserve one memory location to store unsigned int, and as per my requirement, sometimes I can use to store, sometimes I can use that particular memory location to store the address of an integer variable, sometimes I can use that one to store the address of the floating point variable. That is very interesting, isn't it? Although the byte size is different, but again what I am telling, that if it is a character, then 1 byte is required starting from a memory location. If it is an integer, 4 bytes are required starting from a memory location. If it is double, then 8 bytes are required starting from a memory location. So all those will start from a memory location, and the starting memory location is same for all different data types. Even if it is structure, then also it is same. Now the pointer stores only that address. It doesn't store any other information, but while it is storing the address, then it must know when it will be used, that in that memory location what is stored. Is it character or integer or structure or double? So that way it will understand that starting from that memory location, how many bytes required to fetch and how to interpret. Okay. So motivated by this fact, then what we can do is, initially we can declare one pointer variable and make them as void. So I can write void star p. So p is a pointer variable whose data type is void, which means nothing at the beginning. And then whenever there is a requirement that it will store the address of an integer, then I copy the address to that particular memory location and typecast it as integer. Whenever there is a requirement that it will store the address of a floating point number, I will store the floating point number in that memory location and typecast to floating point number. And you see the previous situation of typecasting. So promotion, demotion, that was required. So when I am moving from integer to floating, then it's fine. From floating to double, it's fine. But when I am coming down from double to floating, then there will be a loss of precision. When I am coming down from floating to integer, there will be a loss of information. So when I am coming down from integer to character, since character requires only 1 byte and integer requires 4 byte, so then also there will be loss of information. But in this case, all the situations will require 4 bytes, if I assume that your system required 4 bytes to store unsigned int. So from that point of view, there will be no information loss. All are nothing but the addresses. But during the use, I will basically typecast it, so that going to that address, it can understand how many bytes I need to fetch and how to interpret that one. Okay. So here is the void pointer. So pointers defined to be of specific data type cannot hold the address of another type of variable. It gives syntax error on compilation, else use a void pointer. Okay, that is what I said, that you cannot say declare int star p and then store the address of a floating point variable in p. But what you can do, you can declare void star p, then you store the address of floating point. Because as long as it is void and you are not casting the type, then the compiler knows, okay, type will be cast later. Let us store the address for the time being. But when say you are copying the address of one floating point variable to one integer pointer, then the information that actually this address is the address of a floating is lost. Okay, now it is integer pointer, so it will assume that the address which is given to me is the address of an integer. Okay, so here is one example. In this example, so I initialized value of pi as 3.14128. It is a floating point number. Then integer num, it is 100. This is the integer variable, and then void star p. So initially what I am doing, p is storing the address of pi. Now in this case you see that from storage point of view there will be no mismatch, because pointer will have the 4 bytes, so it will store the address of pi. Next, when I am using this one, then I am doing the typecast. I am telling that p is of type float star, so it is a floating point pointer. And after doing that one, if I print, so it is a typecast to the pointer, and then this parenthesis is for p on which star is given, so that it can print the content of the p, which is the content of the memory location whose address is stored in p. Okay, now after doing this one, what I am doing now, I am having the address of num, the integer variable in p. Again, to use that one, so what I am doing, this blue color indicates that I am typecasting p to integer, and then this parenthesis indicates that that is the pointer variable p which stores the address of one integer variable. With that, if I put star, then it's perfectly okay, and compiler will not complain that %d is expecting an integer and you are providing not an integer. It will not complain. So in that way you can consider as if that void star p is kind of a fresh water, so without any color, without any order. But if you add some color, then its color will change. If you add some order, then its order will change. But this is not a correct example, because after changing that one, that is a permanent change in case of water. But in this case, again it will come back. So again it will be void, because the typecast is done for the usage but not on the variable. Okay, so variable will store 4 bytes, but it is only for the usage. Now that way, if I print, then you will see that pi equals to 3.14128, and this is 100, and without any error, even if you switch on the all wording using WLL, capital W or ALL is small, hyphen and WAL, then you will find that there is no warning, no error, and it will be printing. That the primary reason is this one. Next, just to start with, but in details it will be discussed later, is pointers to pointer. So pointer is a type of data in C, so where the address of that pointer can be stored, and if I wish to store the address of that pointer, then simple thing is that add one more star in front of that one. So if I give double star, okay, so if I say write int star p, then I understand p will store the address of a memory location where a integer variable is stored. Now if I write int star p, which means p will store the address of a memory location which will store the address of a memory location which will store the integer variable. So one more indirection. So 2 stars. If 3 stars, then 3 indirection. That way I can keep on increasing. Now you think, I am not unfolding this one to you right now, that if I give more stars, is that equivalent to more dimensions? So which means 2 star means 2 dimension, 3 star means 3 dimension array. Is that so? Those things will be discussed when multi-dimensional array will be discussed. But a simple example to demonstrate that one. So first line, it is int star iptr and int double star pointer iptr, then simple integer data. Now if I write IPTR, then that is equals to ampersand data, because that is one single interaction. So the content of IPTR is the memory address of a integer variable. Now this pointer IPTR is ampersand IPTR, so it is storing the address of a pointer variable. So the content of PTR IPTR is a memory location which is storing the address of a memory location which is the integer variable. Okay, so two interactions. Now if I write star IPTR equals to 100, then it will go to the content of the IPTR, which is the address of this int data. Then it will go to that data and will change the value of data. And if I print variable data contains data, it will print data because it is changed now. Now if I write star PTR IPTR 200, okay, this was 100, so 100 is printing. If I write using this one 200, then what will happen? First star will indicate that PTR IPTR is storing one address of a pointer variable. It will go to that location, and then second star indicates that it is storing the address of a memory location, go to that, it will go to there, and that is the storage of an integer variable. So that is nothing but this int data, so it will store 200 in that data location. Then if I print, then the second printf statement will output data is 200. Now the final one is the straightforward, that is data 300, and if you print, then you will print the data. Okay, no, so this is star IPTR. So star IPTR means the same thing, and then data content 300 will be printed here. Okay. So now I believe that it is more or less clear to you that why in the scanf we need to provide ampersand, but in say printf it is not required. In printf I need only the content. In scanf it is a function call, so I want that what will be stored in that particular memory location, that will be written when I will come back from the function call. So similar to swap, similar to say min-max computation, I am supplying the address. So that's why this line, although it is blue in color, but it's no, not this way. So you have to access this way. So this way what I am doing, I am creating one memory location in my local system, and I am passing that address to the scanf. Scanf will copy the address location as if call by value, but when it will store, so since it knows that what I have copied is not a content, rather it is an address of some integer variable of whatever, whether integer or floating, that will be come from this %d. So you know by this time this formatting option is for integer, so you need not have to mention that whether x and y is integer or not, it is encoded here. So %d corresponds to ampersand x, this %d corresponds to this ampersand y. So it will inform that okay, so this is my format. So format is like int, so first one is int, second one is also int. So it will understand that okay, I am getting the address of a memory location which is declared for an integer variable. So in that function, when it will read some value, then it will store in that memory location, and since you declared this variable inside this memory, inside this function, so the changes will be reflected here. So you need not have to return it. Okay, so that is the main purpose, and I believe now onwards you will not miss a single ampersand while you are writing scanf rather than the printf. Okay, so that's it for now. Okay, so please go through the slides, practice. Lot of important concepts are declared, and based upon that one, in future we will elaborate more in different context. Okay, thank you very much.